Hello everyone, welcome to my channel Insight. We are back again with another video on Chapter 1 Use of Statistic in Data Science. In the last video, we discussed row-based subset, and today we will be discussing column-based subset. Let's look at the definition before we start working. Sometimes the original data set may contain a large number of columns, and all of them may not be necessary to perform the analysis. As I said in my last video, that all the data which we are not using is not unnecessary. It's that we don't need that data in our analysis. So the necessary data which is needed for analysis to perform analysis all depends on the type of problem we are solving, all depends on the type of condition we have to entertain. So data comes in bulk, data is in large quantity, but we will extract what is relevant to us for the analysis purpose. This process of subsetting is known as column-based subsetting. In this case, we select specific columns from the dataset which we need for the analysis purpose.
This meeting is being recorded.
Today, I wish to bring your attention to one of the data file we will be using for column-based operation. This data, what you are seeing, is a CSV file which I prepared in Excel, and this data refers to the car data, the used car data. This data file consists of 23 car details of various location for different years. It has the kilometers which has been traveled by the car, the fuel type of the car is there, the transmission, whether it is manual or automatic, it is first hand or second hand, that comes the owner type, mileage, the kind of mileage the car is offering, the engine of the car, whether it is more than or less than 1000 cc, the power, the number of seats of the car, the new price and the price. So the new price column, just have a look. Not all the data is available to us. So whatever data is available, we have filled. But when we don't have certain data available, we can handle the situation by entering some values, or we can keep them blank, which can be later entertained in the program. Now, when we are preparing any file, any data in an Excel, we can save that data as a CSV file. So CSV file is a comma separated value file, which can be created in Excel or Notepad or different softwares like Libre Calc or OpenOffice Calc or Google Sheets, and it can be saved as CSV. So to save any file like that, what we have to do is we have to, after preparing the data, we have to click on File, and then we have to save the data. Sorry, as this file is already saved, I'm saving it again with save as, and this time you can select from this operation instead of Excel, you can go for CSV file. After selecting that, give the name and the location of the file where you wish to save and save the file. So this is the data we are using as a CSV file format to entertain the data easily in our Python program. Let's go ahead to our Python program to do analysis on this used car data. Okay, to begin with the programming, it is very important to understand and observe this data again. This data can, how to use the data in the file, and what is the relevance of the data, what kind of analysis we can perform. So there can be a lot of questions related to the same, like performance of the car, listing of the cars on the basis of performance, which location has most used cars sold, and is there more selling of manual cars or automatic cars? Are the first hand car, first owner type car are more preferred over second hand car, or more cars are in demand on the basis of the engine potential? There can be many type of analysis related to the same, but for each type of analysis we have to select which columns can be used, which variables can be used for or can be filtered for the observation part so that we can perform the relevant analysis. Now, how to use the file I just show you, the Excel file which I just show you, I created a CSV file. How can we use this file in the Google Colab? So please look at this thing in your drive. In your drive, whenever you are working on Google Colab, you always have a Colab notebooks folder automatically created in your drive. So when you click here, you can maintain n number of files here. At the same time, you can create folders also. So I have created one of the folder data here to maintain the data we will be using for our Python programs. So this is my first CSV file, which says use car data.csv, which we just created in Excel. The simplest thing is after creating the file in Excel, I uploaded the file we created in our drive by using the file upload option. I just selected the file and open it, and it was uploaded in my drive. Coming to the next step, that is our Python program. So I just showed you the data we are working. I refer to the topic we are working upon, that is column based subset. And I showed you how I created the data in simple Excel file and maintained the same file as a CSV file in my Google Drive. The next step, how can I work with this file data in my Python program? To work upon, the very first thing you have to do is you have to click on the files here. On the left hand side, you see files. It is the fifth icon. So when you click here, you will see the option of Google Drive. So you will see folder like this, a folder which has a drive icon on it. Please click it. The time you click here, it will ask you that you wish to connect to your Google Drive. So you have to connect and give access to the same. So when I'm clicking it, it is giving me the option mounting Google Drive and connect to Google Drive. So you click on this option, connect to Google Drive. Once you do it, above the sample data, your drive will be listed. So drive, whatever folders are there, whatever files are there in the drive, all will be listed here like this. Click here, you will see my drive. So just see the mapping. It's my drive here, my drive. Coming to here in the My Drive, I have Google Notebooks folder. Inside this folder, I have a data folder. In this data folder, you can see my used car data.csv. Now, click on the three dots on the right hand side. Click here and copy the path of file. Right? Copy the path of file. Once it is done, just press the cross here. Come to the bottom line of this image and click on code. So now what we are doing is whatever data I'm reflecting you in front of you as an image, we will actually call the entire data in the program in the data frame from the file. In the last video, in the row based data, as the data was small, I normally created the list and then created the dictionary, and with that I created the data frame. But when the data grow larger, it will be difficult for us to create so many lists and then work upon. So it's better you maintain the data in a file and then call the data from the file to the program. So starting working upon it, the very first step, again, what we have to do is we have to import pandas as PD. And why we are invoking and calling pandas? Because we have to work on data frames. So this is what we are supposed to do. Now after this, what we'll do is we'll just paste the path we copied. This path need to be enclosed in quotes. This path need to be enclosed in quote. Why it need to be enclosed in quote? Because it is a textual data. It is a textual data. It need to be enclosed in quotes. Now, after this, what we have to do is we have to create a data frame. We have to create a data frame by reading the content from the file. So I am creating one of the data frame, that is user card data frame, equal to. Now to access the data from this link, this CSV file, we have to use the PD, the pandas alias. With that, I have to read the file. So this file type is CSV. So you have lot many options. You can read an Excel file, you can read a CSV file. We have to read a CSV file. So as soon as you click here, you can now enclose the entire thing in the bracket like this. So please look at this. What we have done, we have first imported pandas as PD. So PD as an alias, because we are working with data frame, we need pandas for this. User card data frame is my object of data frame, which will get loaded with the data which is coming from the path we have specified. To revise again, I just want to share with you that if you click on files and your drive is, if it is slash like that, that means your drive is mounted. So you don't need to click it back again. So from your drive link, you just click on the three dots here and copy the path of the file which you wish to use and paste at the desired location. So read CSV function of pandas allow me to read the entire data, and this function returns a data frame which is loaded with the content. So we will first see what we have done and what we are fetching from the data, this file. Let's observe that. Let's play it. So this is the data you can see. You have all the headers here. You have all the headers here. You can click on the tabular button here, which allows you to see the data in a see all the records properly in the runtime. So let me click on this. Okay, there is some technical problem. It is not allowing me to do this, but let me show you the data which is much more relevant to see. So as you just scroll down, you can see all the data to the 23 records which you can visualize from this picture. All the records are now fetched from the CSV file. The user card data, used card data is now fetched, and the data frame is automatically constructed on the same. Visualize the blank value, the price column, which has the blank value. This price column, automatically the blank values where the values was not specified, a nan, not a number. Nan refers to not a number, has been provided. So this way, when you see NaN or you see some default value like 0 or something, that gives you a kind of help where you can manage the data if you observe something like this, which can be handled in the program easily, but we will discuss it later. It is not required now. Coming to this, after visualizing the data, let us do some kind of analysis. So what analysis we can do here? Let us extract column subset on the basis of necessity. So for my first need is to predict used car sales city-wise. This is my priority, that I want to extract the column subset on the basis of necessity. And what is my need? That I have to make a prediction of used car sales. So I have a probable, uh, I can make a probable decision that what all columns can I use to do such kind of work. With a random estimate, which can be visualized and observed, I think that I can go for few of the columns where I can have fuel also, kilometers also, location, year, name. So such columns I think will help me to predict, make the prediction for used car sale city wise. Because it is city wise, I think location should be there, then the year of manufacture, the name of the car, the kilometers driven, few things I think should be there. And with this, I constructed one more uh, sub data set, wherein I extracted the columns from the main data frame. The main data frame consists of columns like user, if I display the columns user underscore car underscore data frame, if I click on columns, write columns like this, so and play it, you will be able to see the columns of, okay, I have to put it in print. So the columns will be printed, and with that you can see what all column we have extracted. So we had serial number, name, location, year, kilometers driven, fuel, transmission, so on. Out of these column, I created a column subset of location, year, name, kilometers driven, fuel type, and price. This columns, I think, will help me to make the prediction regarding car sales. So let us print the data of sales city wise data frame to see what all we have extracted. When we are extracting data for any set of columns, then the number of records will not get modified. So if we have 23 records with us, then on fetching up the values of the column, all the 23 records will come, but for the columns we have mentioned. Let's execute and see the output. So this is the output we are getting. We are able to fetch the location, the year, the name as we specified in the order. Location we specified first, then year, then name, then kilometers driven, fuel type, and price. Similarly, our output is coming in the same manner. So this column, this extraction is called column column based subset, wherein as per the need is to predict used car sales city wise. We have lot of work to do on this, lot of analysis can be done on this, but presently we are just talking about how to extract the columns on the basis of condition. So let us go and see more conditions where we can extract the data. With few more examples, I would like to explain the same thing to you. Right. This time, I want to extract the column subset on the basis of necessity, where I have to suggest a five-seater car to one of the client or any of the client. To suggest a five-seater car. So we just saw the number of columns here. We just observe how many columns are being fetched from the main data frame, from the main file, how many columns are there. We have serial number, we have name, location, year, and so many. To provide the analysis for five-seater car, what all do we need? So we have to see the data properly, what all column can make the changes. Like in class ninth, if we say, we talk about the relation between multiple variable. When we say we have multivariate, so multivariate says when we have multiple variables to predict, we are using multiple variables to predict one thing. So in that case, the situation comes when the need arises that we need to extract data of more than one column to work upon. Now, we need to suggest a car. So I am creating one of the data frame with the name car suggest. Car suggests just the name, which is giving a little sense to me that we are creating this data frame to suggest a car to the client. Now, from where we are extracting the data? We are extracting the data from the main data frame, which is user car data frame. From that, we will be extracting set of columns, which I think should be there to suggest a five-seater car to clients. So I have picked up location, year, name, seats, kilometer driven, fuel type, and price. Now, how to make data look more sensible? How to make data more sensible? Okay, okay. But before that, I have to display you the data. That is important, what we have fetched, so that it makes little sense to you. Let me play it. So now, you have location. On this location, in this year, the car which is mentioned here are having different capacity, seating capacity, that is 5, 7, 8, and so on. It has the kilometers driven, the fuel it is using, and the price which is quoted, right? So this is the columns which I think should be part of the analysis. Now, How can I fetch the values on a basis of a condition? My condition is that I want to suggest five-seater car. The data I have fetched is showing me five-seater, seven-seater, eight-seater, right? But I want to show suggestions for five-seater car. So what should I write which help me to get the data set sorted in such a way where my condition is met? So there is one of the function where which can be used with data frame, which allows me to fetch the data and filter out data for more observation. Like this, car suggest, right? This print is not required presently, but I will show you later. This print is presently not required, right? So car suggest is my data frame, which I just fetch up with the data, and you are visualizing the values down. Car suggest dot where. Now this function, whenever used with data frame, it can be used with any data frame we have created, but it is used with this only. Where, and in the bracket, because it's a function, we have the parenthesis opening and closing, right? So in this parenthesis, what we are mentioning is the name of the data set and which value we are comparing. We are comparing seats of the car, which is equal to 5. Double equal to sign is to check the equality of the values. So I want to print all those results where the car has capacity of 5 seats. This is the column I have to compare. That is why I have mentioned seats with the car suggest equal to 5. Now, when we print the result of this, you will see a little difference in the result. That is the normal result coming and how the other values are coming. So this is the previous print result where we are printing the data frame car suggest from this line. And now the output of this line. Let's scroll down to see what output it is coming. See, wherever the seating capacity is not equal to 5, it is more or less, the value is not displaying. It is just displaying the name of the cars where the seating capacity is equal to 5. Where the seating capacity is equal to 5, rest all values are now made blank, unidentified. The given data set is now filtered. Like in this case, if you visualize the data again, you have 5, 7, 8, and so on. But now these cars are not getting displayed. Only the cars which are getting displayed have the seating capacity of 5 seats. Right? Fine. So let us look for more situations now. But before we have to again do one thing, because we are progressing with the data, there is a lot of data we have to scroll up and down. Let's see the columns again. What columns do we have? Because when we are scrolling up and down, there is sometimes we forget what, in case we can miss any column. So we need to visualize it occasionally to see what are there, what kind of information we are holding, right? It is just for this purpose. Now, let us try one more condition where how, like on what case we can extract more columns. So I already showed you two scenarios. One where the car sales we have to predict city wise, and in the second case when we have to suggest five-seater cars to the user. So this time, what we are doing is we are trying to classify the car on the basis of performance. Now just have a look at the columns we have. We have serial number, name, location, year, kilometers driven, fuel type, transmission, owner type, mileage, engine, power, seats, new price, price. So in this case, what do you think we should include when we have to classify the cars on the basis of performance? Which column should we use? Are all column required or we can filter out it? I think we can filter out. So it depends on person to person, like your analysis may be different from my analysis, and we can think differently also. So again, I am like following the same thing. I'm extracting the columns, which I think gives me some results related to performance. Now, how do you judge a car performance? Generally, when you talk about car performance, normally we talk about mileage, which is almost equivalent to the kilometers driven. Transmission of the car are some fixed value. The potential of the car, the power are fixed values. But is what changes? What is volatile? That is the mileage of the car changes and the kilometers driven normally changes. So these are few things which I think should be monitored to check the car's best performance. So what we are doing is we have created a data frame called performance underscore DF, which is being loaded with the data from name, year, kilometers driven, transmission, fuel type, mileage, seats, price. And this time we are doing nothing, but we are uh, sorting the values on the basis of mileage to show the cars. Just doing that. We have already extracted a subset of the data. The column subset has already been extracted in performance underscore DF data frame. And now we are just sorting up the values to show you the uh, outlook, the relevance of the data we have fetched, and how you can visualize the data immediately and get a kind of feedback from the data, like which cars are now best in mileage. And we can classify the cars on various conditions, like on the basis of year or on the basis of mileage and so on. So here you go. This code is sorting the value on the basis of mileage, and we are displaying the values in descending order. That is why there is one of the attribute, the property, which is made to false, that is ascending is made to false, which means we wish to display the data in descending order. In this case, now you can see the highest mileage is coming on the top, and then 26.6, 25.8. So with this you can visualize that the manual cars are giving more mileage as compared to automatic. But in case of BMW here, which is manufactured in 2014, 78,500 kilometers driven, is an automatic car and giving a mileage of 22.69, which is not bad, and rated at 18.55 lakhs. So this is how we see the data. And you can work upon n number of questions related to the same, and then do the analysis. So this is the session related to column-based subset, where we subsetted the columns on different criteria, like we did on the basis of performance, then suggestion of the car, a five-seater car, and then to predict used car sales city-wise. So we worked on three scenarios. You can put more scenarios in the data, and you can work on more analysis. So that's all. Thank you so much for watching.